Hello my schoolers, you are welcome to my school channel. Currently we are tackling the 2018 JAMB pass question for physics. In this clip, we'll be solving questions 64 to 87. Join me as we tackle question 64. Which of the following phenomena is the practical evidence for the existence of the continual motion of molecules? The correct option is C, Brownian motion, okay? The random movement of particles of liquid and gases. Examples are like dispersal of calcium over bones, the dispersal of pollutants in the air, the movement of pollen grains on still water, and the list goes on like that. So the correct option is C, Brownian motion. Here we have question 65. The process by which protons are converted into helium atoms, okay, with a tremendous release of energy is referred to as nuclear fusion or thermonuclear fusion. Okay, the word thermo is used to tell us that it occurs at very high temperature and lots of energy or enormous amount of energy is given off. Okay, example occurs in stars, for example the sun. Okay, hydrogen atoms are being fused together under intense pressure and heat to generate helium atom, okay, which we have here, and a lot of heat energy. So that is why we refer to it as thermonuclear fusion. Okay, option C is very correct. We have question 66. Which of the following is not a product of nuclear fusion? Okay, so you should know from the equation of the reaction or the equation for nuclear fusion. Okay, neutron particle is given out as a subatomic particle, of course. Alpha particles are being given out. Gamma rays too are being emitted, but definitely not X-ray. Okay, so the correct option to the question we are given is option A, X-ray. Remember that all you just have to do is just to click on the link in the description below. It takes you to the Myschool website where you get further information on how you can get the Myschool mobile app or get the Myschool software. All of these tools are made available so that you can be properly prepared for your coming exams. So right now we are tackling the next question. Okay, so a room is heated by means of a charcoal fire. An occupant of the room standing away from the fire is warmed mainly by what process? Okay, just like the way we feel heat from the sun, okay, and we are down here on earth. So this shows that it doesn't require a material medium, okay, for the process to occur, and that definitely describes radiation. So option B is very correct. So you just know that all you have to do to get informed about the videos we are releasing is just for you to hit the like button, click on the subscribe button, and tap on bell notification. Down to question 68. Which of the following phenomena cannot be explained by the molecular theory of matter? This is simply radiation. You recall that radiation is the energy given off by matter, okay, in form of ray or high-speed particles. So option D is very correct. Number 69. The friction which exists between two layers of liquid in relative motion, take note of relative motion, is called what? This is viscosity, just like you comparing the viscosity of palm oil to that of water when you are pouring them from a bottle, okay? Or you realize that viscosity is actually the opposite of fluidity. Okay, so the correct option to the question or to the phenomenon that we've just been given is viscosity. Is actually the friction which exists between two layers of liquid in relative motion. They are trying to oppose movement. Okay, so option C is very correct. Question 70. A particle of mass m initially at rest splits into two. Okay, if one of the particles of mass m moves with velocity v1, the second particle moves with velocity what? Okay, so you recall the law of the conservation of momentum. Okay, so and this is just it. This side is before collision, total momentum before collision, total momentum after collision. So the question tells us that it's from rest, okay? From rest. So that means the velocity is here, there is 0. 0 times m, that is 0. 0 times m, that is 0. So practically on this side we have 0 equals, we are told that one of the particles is m1 with velocity v1, okay? That means the other particle will be the big mass m that's split into 2, okay, minus this other mass that we have been given, the second mass, multiplied by v2. Okay, remember that momentum changes, okay, it's equal in magnitude and opposite in direction. So when this comes here, or when this comes here, we are going to have minus into brackets m minus m1, okay, v2 equals m1 v1. We brought this to this other side, that's why we have the minus sign, okay? So if minus affects everything in the bracket here, so what we are going to have will be minus big M plus small m, okay, over. All right, so, okay, what I'm going to do at this junction is this. I won't let the minus affect it yet to avoid complexity. Okay, so let me just bring it the way it is. Just is the same thing. I just want to make it as simple as possible. Okay, m minus m1. Okay, so m minus m1. Okay, we have the minus sign. So therefore, the second velocity will be equals to m1 v1 over minus times m, that gives you minus m, okay, minus times minus, that gives you plus m1. So we can write this as v2 equals m1 v1 over m1 minus big M. So let's go through our options together. Option B is super correct. Question 71. To keep a vehicle moving at a constant speed V requires power P from the engine. The force provided by the engine is what? Okay, so we're just going to use simple derivatives to get the formula for force. Okay, recall that power equals work done over time taken, okay? Where work done is force times distance still over time, okay? So, and recall that distance from speed equals distance over time, okay? Speed V equals distance over time. Therefore, distance will be speed times time, okay? I think we have this now. So we'll just replace distance here with force times distance is speed times time, okay? Over time. So T strikes out T. So what we have left is force times speed. Force times speed. So what do? We have to make force the subject of the formula. So we divide both sides by V, which is speed. So therefore, the force equals power over speed, P over V. So let's count through our options together. Option A is super correct. Question 72. Which of the following is the dimension of pressure? So let's just make this very easy for ourselves. Okay, this is pressure, force, power, and density. Take note of this. It ought to be 10 raised to power minus 3. Okay, so let me take it again. This is the dimension for pressure, this is for force, this is for power, and this is for density. T raised to power minus 3 rather. So the correct option to the question we are given is option A. Question 73. Palm oil from a bottle flows out more easily after it has been heated because why? On heating, the molecules, okay, they gain more energy and they begin to move faster, okay? And also, we've noticed or we've observed that increase in temperature reduces viscosity in liquids. It is vice versa for gas. So the correct option to this particular phenomenon is that viscosity of the palm oil is reduced on heating. So option B is very correct. Here we have question 74. A ball of mass 5.0 kg hits a smooth vertical wall normally with a speed of 2 meters per second. Determine the magnitude of the resulting impulse. So we recall that impulse is just the product of force and time, okay? Or you can also have impulse as change in momentum. If I will put my impulse as force times time, okay? Let's just use this formula that we are well acquainted with, okay? So we would have force is mass times acceleration, okay, times time, okay? And we know that acceleration is change in velocity over time times this time. Very well. So, okay, so what we still have left is still change in momentum, v minus u. And we are told about the speed of the ball, and that is just 2. Okay, and the mass is 5. That is just 5 times 2. Okay, and that gives you 10. So, if we scan through our options together, option B is very correct. 10 kilogram meter per second. Question 75. The efficiency of energy conversion on the energy flow through a hydroelectric power is what? Okay, there's no diagram to back up whatever formulas that we want to build up, and we don't know what these values represent. Okay, if we have a diagram, it's going to reduce lots of ambiguity. So just for general knowledge, we know that efficiency is just output, okay, over input, the energy that's being used over the energy that is coming in, okay? Sometimes times 100%, depending on what you want. And if you want to get to know the total energy in the whole system, okay, you will just consider the output over input plus the energy lost in the process or energy dissipated to the surrounding, okay? So generally efficiency equals output over input. So that is a very good answer to question 75. Question 76. An object weighs 30 Newton in air and 21 Newton in water. The weight of the object when completely immersed in a liquid of relative density 1.4 is what? Okay, so just recall that relative density of the liquid, okay, equals loss of weight in air, which is, this is weight in air and weight in the liquid over loss of weight in water. That is weight in air minus weight in water. Okay, this is very, very easy. So we see that relative density from the question is 1.4 equals weight in air is 30 minus weight in the liquid, which we are asked to look for, okay, over weight in air 30 minus weight of the liquid in water, which is 21, okay? So we have 1.4 equals 30 minus this, okay? Over 30 minus 21, that is 9. So we'll cross multiply. So we have 9 times 1.4, okay, equals 30 minus weight, okay, in liquid. So having gotten to this junction, what you just have to do is to collect like terms, okay? So we can bring this in to become positive, we'll bring this out to become negative. So we would have equals, let me write it properly, the here should be a subscript, okay? That will be 30 minus 9 times 1.4 gives you 30 minus 12.6. And when we subtract this, we would have 17.4. So we can see from our solution here that the weight of the object when completely immersed in a liquid is 17.4. So going through our options together, option B is very correct. Number 77, which of the following instruments is most suitable for measuring the outside diameter of a narrow pipe in a few millimeters in diameter? Okay, so the instrument that is suitable is a pair of vernier calipers. Okay, you can even use it to measure the internal or external diameter of a tube or the diameter of a rod. Okay, so the correct option here is option A. Question 78. Electrical power is transmitted at a high voltage rather than a low voltage because the amount of energy loss is due to what? Is due to heat dissipation. Okay, just know that high voltage lowers the current, and lower current means lower temperature and lower resistance of the conductor. So option A is very correct. We are at question 79. If the focal length of a camera is 20 centimeters, the distance from the film at which the lens must be set to produce a sharp image of 100 centimeters away is what? Okay, so recall that camera tries to focus the image on the film, and the image of the film, okay, and the camera lens, the distance there is referred to as the image distance. So the image distance is what we are given here, and that is 100 centimeters. So the correct option is option D. Remember that all you need to do is to click on the link in the description below. That takes you to the Myschool website, where you can get further information on how you can download any of the Myschool tools, okay? Either the Myschool mobile app or the Myschool software. So join me as we tackle question number 80. The image of an object is located 6 centimeters behind a convex mirror, okay? If its magnification is 0.6, calculate the focal length of the mirror. So recall that magnification is basically image over object, either size of the image or height of the image over size of the object or height of the object. So we have magnification equals V over U, okay? So we are asked to look for the U, yeah? So we'd have magnification is already 0.6, and we have V, the image, which is 6 centimeters. Cross multiply, so we have U times 0.6 equals 6. Dividing both sides by 0.6, we would have 10. Okay, so object distance is 10 centimeters. So you will recall that 1 over U plus 1 over V equals 1 over F. Okay, this is focal length. Okay, so, and for a convex mirror, the image form, it is virtual and erect. So that implies that V will be negative. So image distance will be -6 since it's formed behind the mirror. Okay, so let's impute this value. So we are going to have 1 over 10. Okay, supposed to be plus, times this minus, so it will become minus 1 over, that is 6, okay, equals 1 over F. So if you find the LCM, you can use 30, okay, equals 1 over F. So this is 10 in 30, that is 3 times 1, that is 3, minus 6 in 30, that is 5, times 1, that is 5. So we'd have 3 minus 5, that is minus 2 over 30 equals 1 over F. When we cross multiply, we have F times minus 2 equals 30 times 1. What do? We divide both sides by minus 2. So F equals minus 15 centimeters. So that's the focal length. So when we scan through our options together, option D is very correct. So do not forget that you just have to hit the like button, click on the subscribe button and tap on bell notifications so you can get informed as soon as the next videos are released. Question 81. A lens of focal length 15 centimeters forms an erect image which is 3 times the size of the object. Okay, the distance between the object and the image is what? Okay, so recall from the question, we are told that the image form is erect, so that tells you that this is definitely not a concave mirror. Okay, so when you remember that the image distance for a convex lens is negative, okay, because it forms a virtual and erect image. So we can now see that it forms an erect image which is 3 times the size of the object. So that is V equals 3 of U, isn't it? So let's use our formula. 1 over F equals 1 over U plus 1 over V. Okay, so since this is a convex lens, okay, it's going to have a negative value. Okay, so that implies 1 over F equals 1 over U. This minus, okay, alters the sign, that is minus 1 over 3 U, isn't it? So if we scan through our options, we are told that through the question rather, we are told that the focal length is 15. So I would switch this to 15. Okay, so let's find the LCM. This is 3U. 3U in this, that is 3 times 1, that gives you 3, minus 3U in 3U, that is 3, that's 1. 1 times 1, that is still 1. Okay, so we would have 1 over 15 equals 3 minus 1, that is 2 over 3U, isn't it? So let's cross multiply. We are going to move up here, so that will be 3U times 1, that is 3U times 1 equals 2 times 15. Okay, so we'll have 3U equals 30, dividing both sides by 3, which is the coefficient of U. Okay, so here we have the object distance as 10, and the distance between the image and the object, okay, that's from the object to the mirror, from the mirror to the image. Okay, so that will be, isn't it? So that gives you 10, okay, plus, remember we said this is 3 times, okay, 3 times of U. That will be 3 times 10, which is 30, and that gives you 40, okay, 40 centimeters. So let's go through our options together. Option D is very correct. Right at question 82. The photocell works on the principle of the what? That's on the principle of emission of electrons by incidence radiation. You know, it has a photosensitive cathode, okay, that emits electrons which are going to be absorbed, okay, or collected by the anode. Okay, so the correct option is B. Photovoltaic cell, just about chemical action relating to electric current. Photographic plates, a plate that captures photographic image. Okay, so the correct option is option B. We are tackling question 83. When a known standard resistor of 2.0 ohms or omega is connected to the 0.0 centimeter end of the meter bridge, okay, the balance point is found to be at 55.0 centimeter. This is just very, very easy to tackle. So just use this. R1 over R2 equals L1 over L2. Okay, this is the unknown resistance. Okay, this is the standard resistor. This is from A, okay, which is your balance point. This is where you get your balance point from. And this shows you like the remaining distance, which is 100 minus L1. Okay, so let's slot this in. Okay, so we have an unknown resistance, okay, which is R1 over the standard resistor from the question is 2. 2 equals, the balance point is 55. over L2, which is 100 minus L1, which is 55. Okay, so 100 minus 55, that is 45. So let's make it easier. So we'll have 45. Okay, so what do? We cross multiply. So we have 45 times the unknown resistance equals 55 times 2. Okay, dividing both sides by 45. Okay, we can say 5 here 9, 5 here 11. So that is 22 over 9. That gives you 2.44444 whatever ohms. So let's count through our options. We see that option C is very correct. This is question 84. A resistor connected to a 12-volt battery draws a current of 2 amperes. The energy dispatched in the resistor in 5 minutes is what? Okay, so we just have to use simple derivatives where we have power equals current, okay, times voltage. All right, so we say from the question that the current is 2, the voltage is 12. Okay, so that is 2 times 12, and that gives you 24 watts. Okay, so very well, we are now asked to calculate energy, and we recall that power equals energy over time. That means energy equals power times time. Okay, the power here is 24. The time given is 5 minutes, so it has to be 5 times 60 to bring it to seconds. Okay, so that implies 24 times 5 times 60, that is 300. Okay, 3 times 4, that is 7200. Okay, energy is measured in joules. So when we go through our options together, option C is very correct. So we have question 85. A solid weighs 45 Newton and 15 Newton respectively in air and water. Determine the relative density of the solid. Okay, that just gives us weight of the substance or the solid in air over upthrust. Okay, weight in air, okay, over upthrust, and upthrust is the total weight minus the apparent weight. Okay, or just say loss of weight in water. Okay, that will be the weight in air minus the weight in water. Okay, and the weight in air is 45. The loss in weight in water, that will be 45 minus 15. That gives you 45 over 30. Okay, 15 here 2, 15 here 3. Relative density equals 3 over 2 or 1.5. So join me as we scan through our options together. Option C is very correct. 86. A boy receives the echo of his clap reflected by a nearby hill 0.8 seconds later. Okay, if the speed of sound in air is 340 meters per second, how far is he from the hill? This is very simple. Recall that echo, okay, equals 2x over t. The reason why we have 2 of these x is because the distance from your voice or from the clap hitting the hill then coming back to you. So distance to go, distance to come back, to and fro. Okay, that's why we have 2. All right, so we have to find the distance x. So what do? We cross multiply. So we have v times t equals 2x, dividing both sides by 2. So we'd have distance x equals vt over 2. So we know that the speed of sound in air is 340. All right, times the time is 0.8 seconds divided by 2. Okay, 2 here 1, 2 here 170. Okay, so basically we'll just have x equals 170 times 0.8 or 170 times 8 over 10, whatever thing you want to do, 8 over 10 or 4 over 5, okay? Isn't it? Or 8 over 10. So we have 5 here, 1, 5 in 17, that is 3, remainder 2, 5 in 20, that is 4. Okay, so we have 34 times 4. And you can just do something like this. And all of these exercises is just to engage us without using our calculators. Okay, 4 times 4, that is 16. You carry 1. 4 times 3, that is 12, plus 1, that is 13. So we'd have the distance equals 136 meters. So join me as we go through our options together, and we'll see that option B is very correct. Number 87. The critical angle for light traveling from a transparent medium to air is measured as 34 degrees. Okay? The refractive index of the medium is what? So just use a simple formula that refractive index equals 1 over sine theta. The sine theta means the critical angle, 1 over critical angle, okay? So that is refractive index equals 1 over, the critical angle is 34 degrees, so that is 1 over sine 34 degrees, okay? That is 1 over 0.55919. And when we divide this, we are going to have roughly 1.79. So the refractive index is 1.79. So if we go through the options together, option C is very correct. We've come to the end of the solutions for the 2018 JAMB past question physics, okay? But there is definitely more to come. We believe you enjoy this content and you would like us to bring you more. All you just have to do is to hit the like button, click on the subscribe button and tap on bell notifications so you can get informed as soon as the next videos are uploaded.